The past couple of problems have dealt with the natural log. Let's look at another common problem that doesn't deal with the natural log, but is going to require us to make a little change to our function in order to satisfy the domain. So we see, oops, there we go. We see right here we have dy dx is equal to x over y. How are we going to get y over to the left side? Yeah, we're going to multiply. All right, same thing with the dx. So when we multiply both sides by y, and we multiply both sides by dx, we end up with y dy equals x dx. All right, so when it comes time to antiderive this, not so bad at all. All right, antiderivative symbol, antiderivative symbol. This would be one of those problems where the antiderivatives would be worth 1 point instead of 2 because there's really not all that much going on there. Okay, so we have y squared over 2 equals x squared over 2 plus c. And we know that when we plug in -3 for x and -2 for y, that's going to give us our value for c. All right, so we're going to have -2 squared over 2, and that's equal to -3 squared over 2 plus c. All right, -2 squared is 4, so we have 4 over 2. -3 squared is 9, so we have 9 over 2. Looks like a minus sign, let's make that an equals, plus c. So if we subtract 9/2 from both sides, we see that c is equal to -5 over 2. We solve for c using the initial condition. Step 4 is done. Now let's figure out what y is. So to recap what's going on here, we have y squared over 2 equals x squared over 2 minus 5 over 2, right? Because we're adding -5/2. Let's get y all by itself. How do we get rid of the 2? Exactly, multiply everything by 2. So we end up having y squared is equal to x squared minus 5. How do we get rid of the square? So yeah, we're going to take the square root. So we have y is equal to the square root of x squared minus 5. Right? Now at this point, many students often think, okay, we're done. We got y all by itself. We've got to be careful here though, because remember what we just did. We took a square root while we're trying to solve an equation. And we know that if we're taking the square root, when we're solving an equation, the answer could be positive or negative. All right? If you recall back to your algebra class, let's just go right up here. If you were told that x squared was equal to, let's say, 49, all right? Your teachers taught you that there's actually 2 answers to that equation. X could be 7, or x could be -7. So in other words, x could be plus or minus 7. We have to do the same thing right here. When we take the square root, there's actually a plus or minus in front of that square root as we're working to solve our equation. Now this is not an acceptable answer because this is not a function, all right? Keep in mind that we're dealing with basically y is equal to the square root of x squared. So what's going on here is we're getting basically this kind of function going on, okay? We're getting a sideways parabola, or parabola that opens up to the right. That fails the vertical line test. So we don't want both halves of it. We either want the positive half or the negative half. And the question is, which one is it? And the answer is, it all depends on the initial condition. The initial condition says that our function has to go through the point back 3 down 2. Oops, I got my y-axis in the wrong spot here. There we go. It's got to go through the point back 3 down 2. So if we go back 3 down 2, that's that point right there, which means that we want the bottom half of our differential equation. We don't want the top half at all. So in other words, we want the negative part. I'm going to erase the plus sign right here, and now I have my final answer. Y is equal to the opposite of the square root of the quantity x squared minus 5.